So imagine waking up to this. A sky that just doesn't change. You've got one sun that hangs there forever. Another huge bright disk floating by. And a third that's just a tiny, faraway speck of fire. Now, this isn't some sci-fi movie. This is the wild reality we're designing for the first human pioneers on a planet called TRAPPIST-1e, a world 40 light-years from home. But hold on. Before you start packing your bags, let's get one thing straight. You've probably heard this place has 3 suns. That's not what's happening here. There's only one star, TRAPPIST-1. Those other bright things in the sky, they're other planets, neighbors. So close, they'd look like giant moons. They don't make their own light. They just reflect the stars. But the view would be absolutely epic. Now for the bad news. This planet is actively trying to kill you. One side is a permanently scorched, irradiated wasteland, and the other side is a frozen, endless night. Survival seems impossible, except for one little sliver of real estate, a narrow strip of permanent twilight right down the middle. This is the story of how we could actually build a city on the edge of light and shadow. It's a blueprint for not dying, a huge engineering puzzle, and maybe, just maybe, a peek at our future out there among the stars. Before we can even think about building a home, we need to get real about the monster we're trying to tame. TRAPPIST-1e is not Earth 2.0. It orbits a star so different from our sun that it basically rewrites the entire rulebook for survival. The star, TRAPPIST-1, is an ultra-cool red dwarf. It's old, it's dim, and it glows with this kind of spooky, cherry red light. But because the planet is so close to it, we get a bunch of extreme problems that make Mars look like a vacation spot. The biggest issue is something called tidal locking. Just like how the moon always shows the same face to Earth, TRAPPIST-1e is stuck. One side of the planet, the day side, is trapped in a forever day. The other side, the night side, is cursed with a permanent, starless night. There's no morning, no evening, just a baked-in geography of fire and ice. Okay, so let's say you touch down on the day side first. This is where the dim red sun just hangs in the sky, never moving. You might think, dim sun, gentle warmth, right? Not so fast. The planet is technically in the habitable zone, which just means it's at the right distance for liquid water, if it has the right atmosphere. But the James Webb Space Telescope gave us our first big clue about this world. It pretty much ruled out a thick, puffy hydrogen atmosphere. Without that kind of atmosphere to spread the heat around, this side just bakes under constant energy. And the star itself is violent. It has these frequent, massive flare events that blast the system with X-rays and charged particles, a lethal cocktail that would sterilize this whole side of the planet. So the day side isn't a paradise. It's a radiated, reddish desert under a sun that never, ever sets. Now, let's hop 180 degrees around the planet into the endless night. Here you've got the opposite problem. This side never sees the star's light. Without a thick atmosphere to trap and move heat from the hot side, any warmth just radiates away into space. Temperatures would drop to hundreds of degrees below zero. It would be so ridiculously cold that gases like carbon dioxide could freeze solid and literally snow down, forming huge glaciers of frozen air. This side is a silent, frozen wasteland. So one side's an oven, the other's a freezer. Neither place is gonna work. You travel 40 light years, a trip that would take generations or some physics-bending spaceship, only to arrive at a world that wants you dead on both sides. So how do you settle a planet like that? The answer, it turns out, wasn't on either side, but right in between. The solution is in a simple but crazy-sounding concept, the Terminator line. On Earth, we call this sunrise and sunset. But on a tidally locked world like TRAPPIST-1e, the Terminator is a permanent place. It's a thin, fixed ring of perpetual twilight that goes all the way around the planet. And in this twilight zone, the conditions for life might actually be, well, balmy. Here, the red dwarf star, TRAPPIST-1, is always sitting right on the horizon, bathing everything in a constant, dusky red glow. The temperature isn't scorching, and it's not freezing. It's a gradient, a delicate balance between the two extremes. Climate models predicted this would be the one place where liquid water could exist. You can imagine huge glaciers from the nightside, slowly melting as they touch the warmer twilight zone, creating rivers and lakes, the key ingredient for setting up shop. But this zone wouldn't be peaceful. The massive temperature difference between the baked dayside and the frozen nightside would create a crazy atmospheric engine. Hot air on one side would rise, cold air on the other would sink, and you'd get these insane, powerful winds howling non-stop along the Terminator line. To the first settlers, it would sound like a terrifying, planet-sized hurricane. But to an engineer, it sounded like an opportunity. It sounded like power, limitless, predictable, never-ending power. The real breakthrough moment, the thing that let us go from what if to how to, came from the James Webb Space Telescope. For a long time, there was this nagging fear that TRAPPIST-1e might be a mini Neptune, a gas planet with no solid surface to land on. If that were true, game over. But the JWST analyzed the starlight filtering through the planet's atmosphere and found no evidence of a big, puffy hydrogen envelope. The planet was rocky. That single discovery kept the dream alive. While the data couldn't confirm a heavier atmosphere, like one made of nitrogen or CO2 from volcanoes, it left that door wide open. And that little sliver of hope was all we needed to start drawing up blueprints. We had a target, a rocky, Earth-sized world in the right spot for water, with a potential atmosphere and a built-in power source. The Twilight Zone was no longer just a theory, it was a destination. The sanctuary was found. This is what human exploration is all about, right? We take the impossible and start figuring out the how. If you're fascinated by the insane challenges of building a city on another world, hit that subscribe button and stick around. We're just getting started. Okay, now that we have a spot, the real work begins. Building a city for 100,000 people. A city we'll call Aurora, in the twilight zone of a world 40 light years away. This isn't a weekend project. It's a multi-generational plan of robots, grit, and a whole lot of engineering. First things first, you can't just build a city out in the open where those crazy Terminator winds will rip it apart. The first wave of the mission, way before any human gets there, would be all robots. Probes would get into orbit and map the Terminator zone, looking for one thing: shelter. They'd be searching for huge, natural geological features, like deep canyons or rift valleys, that could shield a city from the worst of the wind and radiation. Once they find the perfect canyon, the next wave of robots descends. Think of a fleet of autonomous 3D printers and construction drones. Their building material, the planet itself, the rock and dust on the canyon floor. They'd get to work, slowly printing the foundations of the first human outpost. At the same time, other robots would set up the first power source, heavily armored wind turbines, designed to catch the powerful winds funneling through the canyon. For months, maybe years, these machines would work in the dim red light, getting a foothold ready before their creators show up. Power is the lifeblood of Denny City, and in Aurora, it's everything. The plan hinges on 3 main power sources, so if one fails, you're not totally screwed. The first and most important is the wind. Those first turbines are just the start. The master plan calls for a huge network of thousands of turbines along the canyon ridges. Unlike wind power on Earth, which is totally unpredictable, these winds are a constant. As long as one side of the planet is hot and the other is cold, the wind will blow. That gives you a reliable baseline of power that never stops. The second source is underground. The same tidal forces that locked the planet in place are probably squeezing and stretching its insides, which could create a lot of geothermal heat. The plan is to drill deep into the canyon floor to tap into that internal heat. These geothermal plants would be a totally separate, stable source of energy, crucial for running the city and its life support. The third source is the star itself. TRAPPIST-1 is dim, but it's always there. Solar panels wouldn't be laid out flat like on Earth. Instead, you'd mount them vertically on the canyon wall that faces the day side, permanently aimed at that unmoving red sun on the horizon. These panels would be specially designed to be super efficient at catching the infrared light that red dwarfs mostly emit. Together, this trinity of power, wind, geothermal, and solar, creates a tough and reliable energy grid. Okay, you've got power. Now for the really important stuff: water and air. Models suggest we could find water in the Terminator zone, but we'd have to harvest it. One way is to pull it right out of the air. We could build giant condenser arrays, basically massive dehumidifiers, powered by the city's endless energy supply. The other plan is more ambitious. Robotic mining stations would travel to the edge of the giant nightside ice cap. Right at that border, where absolute zero meets the gentle warmth of the twilight zone, you could have massive reserves of frozen water. The robots would melt this ice and pump it back to the city through insulated pipelines. This would be Aurora's main water supply, a river of life flowing from the land of eternal ice. As for breathable air, that's a long-term project. At first, All the habitats would be sealed tight, with air brought from Earth and recycled with almost perfect efficiency. But to support 100,000 people, you need to make your own. The first step would be to see what's in the native atmosphere. If it has a lot of carbon dioxide from volcanoes, we could deploy devices similar to NASA's MOXIE experiment on Mars, but on a massive scale. These machines would split the CO2, releasing oxygen that we could use to fill bigger and bigger sealed sections of the city. So you have power, water, and air. How do you feed everyone? There's no soil and no sunshine that Earth plants would recognize. You have to reinvent farming. The solution is to go down. Deep under the main city levels, you'd carve out huge, multi-story caverns and turn them into farms. These wouldn't be normal farms. They'd be massive hydroponic and aeroponic facilities where crops grow in nutrient-rich water or mist with no soil at all. The sunlight would come from custom-tuned LED lights, glowing pink and purple, optimized for photosynthesis. Powered by the city's grid, these lights would run on a programmed cycle, giving the plants a fake day and night. The crops themselves would be genetically engineered wonders, designed for high yield and low resource use. You'd grow staples like potatoes, rice, and soybeans, alongside algae that's rich in protein. Not exactly gourmet, but it's enough to sustain you. Every drop of water, every bit of waste would be meticulously recycled. In the farms of Aurora, nothing is wasted. This is how you feed a city in the dark. With all the survival stuff figured out, the city itself can finally take shape. Aurora wouldn't be a city of towers reaching for the sky. It would be built into the planet itself. Instead of skyscrapers, think ground scrapers carved deep into the canyon walls, with windows looking out at that permanent, breathtaking sunset. The 100,000 residents would live in these carved-out sectors, all connected by silent maglev trains in pressurized tunnels. The city center wouldn't be a plaza, but a gigantic central cavern, hundreds of meters high, with a massive screen on the ceiling that could simulate Earth's blue sky or show live feeds from space. This grand cavern would be the social heart of Aurora, a place for parks, markets, and just hanging out, all designed to keep people from going stir-crazy. Building the city is one thing. Living in it? That's a whole other problem. What would daily life actually be like for the 100,000 people in Aurora, a city stuck between eternal day and endless night? The biggest mind-bender, no day and night. Time would be completely artificial. The city would run on a 24-hour clock just for sanity's sake, but morning and evening would be meaningless. Work shifts would dictate your life. To maintain everyone's sanity, the city's lighting would have to mimic a 24-hour cycle, gently brightening and dimming, and the big screen in the grand cavern would show a fake blue sky that turns to stars at night. And then there's the real sky. From a viewing deck high up in the canyon, the view would be incredible. The star, TRAPPIST-1, would just hang there on the horizon, a huge, dim, red orb casting long shadows that never move. But the real show is the other planets in the system. They orbit so close to each other that they wouldn't just be dots of light. They would appear as huge, brilliant disks in the sky, maybe even bigger than our moon. They aren't suns, they just reflect the star's light. But watching the crescent of a neighboring planet drift across the sky would be a cultural event, a shared moment of wonder for everyone in Aurora. The economy would be completely different. Forget the stock market or advertising. Every single job would be essential. Most people would be engineers and technicians, the ones keeping the city from falling apart. They'd be the heroes of this new world, constantly checking the turbines, maintaining the life support, and making sure the systems never, ever fail. A close second would be the scientists. Geologists would explore the Terminator zone in armored rovers, looking for minerals. Astronomers would have a dream observatory with a perfectly clear view of the galaxy. And biologists would have the most exciting job of all, searching for any sign of native life, a discovery that would change everything. Then you'd have the high-tech farmers, the artists, the musicians, and the storytellers. In a world of recycled air and engineered rock, culture would be what keeps the human spirit alive. They'd pass down the story of the long journey from Earth, making sure no one ever forgets the pale blue dot they came from. But life wouldn't be totally safe. Outside the city walls, the planet is still a killer. A tear in your spacesuit could be fatal. Equipment failure is a death sentence. And you always have to worry about a big solar flare. Even with the canyon for protection, a major flare could force everyone to hunker down and go on high alert. Building Aurora on TRAPPIST-1e would be more than just an engineering victory. It would be a turning point for our entire species. The moment the first child is born there, humanity is no longer a single-planet species. Our eggs would no longer all be in one basket. Imagine standing on that observation deck, looking out at the permanent twilight. In the sky, you see the massive disk of a sister planet, and beyond it, a field of alien stars. One of those faint little dots of light is our sun, Sol, and around it, too small to see, is Earth. From 40 light-years away, all of human history, our art, our wars, our triumphs, is contained in that one tiny speck. That perspective would change everything. The old divisions of nation and tribe would seem totally absurd. The people of Aurora wouldn't be from one country or another. They would just be human, united by the insane, breathtaking reality of their new home. Look, building a city on TRAPPIST-1e is a thought experiment today, based on the first drips of data we're getting from new telescopes. It's not science fiction, but it is a plausible future. The challenges are huge. It would demand breakthroughs in space travel to even get there, in robotics to build the city, and in biology to keep everyone alive. But the history of humanity is a story of doing impossible things. We climbed out of the trees, we crossed oceans, we walked on the moon. We do these things because that drive to explore, to see what's over the next hill or past the next star, is basically written into our DNA. The dream of building a city like Aurora is about more than just survival. It's about purpose. It's about making sure that the little flicker of consciousness that started on Earth gets a chance to see what else is out there. It's a new dawn for humanity, waiting for us in the perpetual twilight of a world 40 light years away. What do you think would be the greatest non-engineering challenge of living in the Twilight City? The psychology, the government, the art? Let us know your thoughts in the comments below. And for more journeys to the frontiers of science and imagination, make sure you subscribe and ring that notification bell, because the future is out there, waiting to be built.